Hello to everyone. In this session, we have to discuss about Cauchy's general principle of convergence of a sequence. The definition of Cauchy sequence: a sequence xn is called a Cauchy sequence or a fundamental sequence if for epsilon greater than 0 there exists a positive integer m such that modulus of xn plus p minus xn less than epsilon for all n greater than or equal to m and p greater than or equal to 1. Theorem: the necessary and sufficient condition for the convergence of a sequence xn is that for each epsilon greater than 0, there exists a positive integer m such that modulus of xn plus p minus xn less than epsilon for all n greater than or equal to m, comma, p greater than or equal to 1. Proof of this theorem: let the sequence be convergent and L be its limit, so that for a given epsilon greater than 0, there exists a positive integer m such that modulus of xn minus L less than epsilon by 2. So for all n greater than or equal to m. If p greater than or equal to 1, then n plus p greater than or equal to n greater than or equal to m. And so modulus of xn plus p minus xn less than epsilon by 2 for all n greater than or equal to m, comma, p greater than or equal to 1. Next, modulus of xn plus p minus xn, that is equal to modulus of xn plus p minus l plus l minus xn. Here we have to add and subtract l. So that is less than or equal to modulus of xn plus p minus l plus modulus of l minus xn, that is less than epsilon by 2 plus epsilon by 2. So by the definition of limit of a sequence. So that implies modulus of xn plus p minus xn less than epsilon for all n greater than or equal to m, comma, p greater than or equal to 1. So this is the necessary condition. Then sufficient condition. To establish the convergence of the sequence as a consequence of the given conditions, we have shown first that sequence is bounded and then that is convergence to a finite value. Now, by the given condition for epsilon is equal to 1, there exists a positive integer m such that modulus of xn plus p minus xn less than L for all n greater than or equal to m, p greater than or equal to 1. So in particular, for n is equal to m naught, so modulus of x m naught plus p minus x m naught less than L for all p greater than or equal to 1. So that means x m naught minus L less than x m naught plus p less than x m naught plus 1. So p greater than or equal to 1. So next line, let G is equal to minimum of S1, S2, S m naught minus 1. So S m naught plus 1. And capital G is equal to maximum of S1, S2, S m naught minus 1, comma, S m naught plus 1. So then here sequence Sn lies in between small g and capital G for all n. Hence the sequence is bounded and therefore the sequence, it has at least one limit point, so that is L. You shall show that the sequence converges to L. So that is limit of xn as n tends to infinity is equal to L. Next, Now, by the given condition for epsilon greater than 0, there exists a positive integer m such that modulus of xn plus p minus xn less than epsilon by 3 for all n greater than or equal to m, comma p greater than or equal to 1. So, in particular, for n is equal to m, modulus of xn plus p minus xn less than epsilon by 3 for all p greater than or equal to 1. So, call this equation number 1. As L is a limit point, there exists an integer m1 greater than m such that modulus of x m1 minus L less than epsilon by 3. So call this equation number 2. So also, since m1 greater than m, from equation 1 we have modulus of xm1 minus xm less than epsilon by 3. So this is equation 3. So then modulus of xm plus p minus l is equal to modulus of xm plus p minus xm plus xm minus xm1 plus xm1 minus l. So here we have to add and subtract xm and xm1. So that is less than or is equal to modulus of xm plus p minus xm plus modulus of xm minus xm1 plus modulus of xm1 minus l. So that implies modulus of x m plus p minus l less than epsilon by 3 plus epsilon by 3 plus epsilon by 3. So that is less than epsilon for all p greater than or equal to 1. So that implies modulus of xn minus l less than epsilon for all n greater than or equal to m. Hence the sequence xn is converges to n. So next examples. The first one, show that the sequence xn where xn is equal to 1 plus 1 by 2 plus 1 by 3 up to 1 by n cannot converge. So solution. So take epsilon is equal to half and p is equal to n is equal to m in Cauchy's general principle of convergence, so that xn plus p minus xn is equal to x2n x2m minus xm, that is equal to 1 by m plus 1 1 plus 1 by m plus 2 up to 1 by 2m. So that is greater than 1 by 2m plus 1 by 2 up to plus 1 by 2m. That means m times 1 by 2m, there get cancelled, we get half. So thus modulus of xn plus p minus xn greater than half, which is contradicts Cauchy's general principle of convergence, hence the sequence cannot converge. So next example, show that the sequence whose nth term is minus 1 raised to n is not a Cauchy sequence. Solution. So x here xn is equal to minus 1 raised to n. Let p is equal to 2m plus 1 and q is equal to 2m, so that here pq greater than m. Now modulus of xp minus xq is equal to modulus of minus 1 raised to 2m plus 1 minus 1 raised to 2m, that is equal to minus 1, so that is equal to 2. So therefore if epsilon is equal to half, it is not possible to find any positive integer m such that xp my modulus of xp minus xq less than epsilon for all p comma q greater than m. So this implies xn is not Cauchy sequence. So revision, in this session we have to discuss about Cauchy's general principle of convergence of a sequence. So these are the reference books used in this session. So thank you one and all.